Okay, we have here this the random variable x is a distribution. This is already a normal distribution, so we can write it as x is normally distributed with this mu, and this is like standard notation of this, and it says mu is 1.5 times sigma. Random value of x is chosen. Find the probability that this value of x is greater than 0. So we have to find the probability that x is greater than 0. Without wasting our time, we'll standardize this. Z is greater than 0 minus mu over the standard deviation. Okay. So this is going to be probability Z is greater than, I'll change this mu with from here. Okay. So this is going to be greater than minus 1.5 sigma over sigma. Okay. Okay, so we had been up to this part. So I'll be canceling the sigma sign with the sigma sign. So we are left with z is greater than minus 1.5. You have the greater than sign and then there is a minus. This can be changed with phi of 1.5. We go to the table and see what is phi of 1.5. That is 0.9332, 0.9332, 0.9332. That is what we have here. Okay, so that is it. You see, you have to find the probability that x is greater than 0. Then we go into the second part, and it says the life of a particular, let me clear this. The life of a particular type of torch battery is normally distributed with this mean and this standard deviation. Okay, so we'll say, okay, let y is normally distributed. This is the mean here, and this is the standard deviation. And we write the variance here. It is known that 87.5% of these batteries last longer than 70 hours. Okay, probability x is more than 70 is 0.875. That is how I'm going to use this 87.5%. So we have to find the value of s. No problem. You start by standardizing this. So this is going to be probability z is greater than 70 minus 120 over the square root of this variance, and that is 0.875. Okay, so this is probability z is greater than minus 50 over s, that is 0.875. There is this greater, there is this minus, and this is already more than 0.5. So we are happy to have all this. So I can simply change this with phi of 50 over s, that is 0.875. So this 50 over s is going to be phi inverse of 0.875. Let's go to the table and see what is phi inverse of 0.875. So guys, where do I have this 0.875? Let me see. Okay, this 0.875. Yeah, 0.875. 0.875 is, yeah, it is somewhere very close to this. Maybe we can add this 2 into it. This would give us 0.8751. So it is 1.1, 1, 2, 3, 4, 5, 1.151, 1.51, 1.151. Okay, I'm going to go back to the paper. So this is your 50 over S. So your S is 50 over 1.51. That was the standard deviation. So this is 50 divided by 1.151. That is 43.4. So this is the required value of the standard deviation. That's it from the day, guys. Thank you very much.